Hello friends, continuing with the topic Venn diagram high voltage generator. Today we take up next part of it, that is part 2, Venn diagram high voltage generator and particle accelerator. Our topic today is Venn diagram high voltage generator and particle accelerator. First, construction. A. High voltage electrode E is a spherical hollow conducting shell mounted over an insulated stand S1 at a certain height above surface of ground, as shown in diagram. B. Pulleys P1 and P2 are fixed inside the shell. P1 is fixed at the center of the shell and P2 near high tension HT supply. C. Conveyor belt C runs over these pulleys with the help of an electric motor M. D. Electric motor M drives the conveyor belt in clockwise direction when switched on. E. Combs C1 and C2 are fixed near conveyor belt in such a way that sharp pins of the combs are just near the belt, as shown in diagram. Cob C1 is connected internally with hollow conducting shell and C2 is connected to high tension power supply. F. Particle source S and target T arrangement in a vacuum tube. The particle source S, target and target T arrangement is fixed inside for acceleration of the particles like protons or alpha particles. G. High tension power supply supplies necessary charge through comb C2 over the conveyor belt, following the principle that charge has a tendency to reside over sharp points. H. Terminal TE, from which high voltage can be derived. A terminal TE is connected to the spherical conducting shell from which we derive the high voltage. This is all about construction of Venn diagram high voltage generator and particle accelerator. Now we go for working. 2. Working. Working we study in two parts: A. High voltage generation and B. Particle acceleration. We take up one by one. First we take up A. High voltage generation. Now motor M is switched on. Conveyor belt runs over pulleys P1 and P2. HT supply is switched on. It supplies charge on conveyor belt through comb C2, which acts on the principle that charge has a tendency to reside on sharp points. This charge is carried by conveyor belt towards pulley P1, where comb C1 collects this charge from conveyor belt and again on the principle of sharp points. The charge collected by comb C1 is transferred to outer surface of hollow conducting sphere, being internally connected to it. This process keeps on till desired voltages are built up. It can build up millions of volts and electric fields of the order of breakdown field of air, which is 3 into 10 raised to power 6 volts per meter. For example, a sphere of radius 1 meter can be raised maximum to a potential of 3 into 10 raised to power 6 volts, and maximum field that can be held is 3 into 10 raised to power 6 volt per meter, because we know E is equal to V by R. Here V is 3 into 10 raised to power 6 volt and R is 1 meter. So the breakdown field would be 3 into 10 raised to power 6 volt per meter, being the breakdown field of air. Okay. B. Particle acceleration. After learning about high voltage generation, now we come to particle acceleration. Protons or alpha particles which are to be accelerated are introduced into an accelerating tube at one end of the evacuated tube placed inside the shell. Due to high positive charge accumulated over shell, these are repelled with a tremendous electrostatic force and are accelerated. Finally, these accelerated particles are made to hit a target T placed on the other side of the tube. This way, we have particle acceleration with the help of Van de Graaff high voltage generator. Okay. 3 advantages. Number 1, it is used as a proton accelerator. Number 2, protons accelerated by this machine are used to study proton-proton scattering to investigate many other nuclear reactions. 3. Electrons can also be accelerated by this machine by reversing the nature of charge accumulated on high voltage electrode. If we give negative charge to high voltage electrode, then we can accelerate electrons with this machine also. Okay. These are 3 advantages of Van de Graaff high voltage generator and particle accelerator. Now 4th part is limitations. What are limitations of it? Number 1, the direct use of high voltage is a serious drawback in itself. Number 2, the experimental difficulties increase rapidly with increasing voltage. Number 3, leakage of charge can take place at very high voltage. So these are 3 limitations of this machine. Now 5th part of this topic is how to minimize leakage. Leakage can be minimized by making surface of high voltage electrode, that is spherical conducting shell, perfectly smooth. So by making the surface of high voltage electrode perfectly smooth, we can minimize leakage. Assignment 2.4 continued. Question number 3. State and prove principle of Van de Graaff high voltage generator. Question number 4. With the help of labeled diagram, explain construction and working of Van de Graaff high voltage generator. How particles are accelerated by it. Question number 5. What are advantages of Van de Graaff high voltage generator? Question number 6. What are the limitations of Van de Graaff high voltage generator? Question number 7. How leakage is minimized in Van de Graaff high voltage generator? Question number 8. In a Van de Graaff type generator, a spherical metal shell is to be a 15 into 10 raised to power 6 volt electrode. The dielectric strength of the gas surrounding the electrode is 5 into 10 raised to power 7 volt per meter. Calculate maximum radius of the shell. So hint is use relation V is equal to E into R. So from here we calculate R is equal to V by E, and then you can put it as 15 into 10 raised to power 6 divided by 5 into 10 raised to power 7. So it will be equal to 0.3 meter. So R is equal to 3 centimeter is the answer to this question. Thank you so much. With this, we finish with the unit of electrostatics. Next time, we will start with current electricity. Till then, goodbye.